Hey, everybody, welcome. We're going to go ahead and let folks start coming into the Zoom room. Thank you all for joining us today. We are so excited to talk about our back to school essentials with you all today. While we're waiting for more friends to come into the Zoom room, let's make sure that we are all situated on Zoom. So to get started, please navigate to the bottom of your Zoom window and click that little chat icon. It kind of looks like a chat bubble. When you click that, you'll be able to type into the webinar chat and just make sure your to section is set to everyone. And that just makes sure that when you ask us your questions, everyone can see your question. Nüs and Josh will be answering your questions during the webinar. So we appreciate when you make your chat visible to everyone so they don't look like they're talking to themselves. And that being said, once you have your Zoom window chat box open, go ahead and let us know what you're looking forward to most about going back to school. And remember to set your response to everyone so we can all see, we can all get excited for the new school year together. It looks like we have someone that recognized Noose. That's awesome. Wonderful. Barbara says she loves teaching school. That's great. Seeing students using Vernier equipment, we love to hear that. Oh my gosh, somebody's back in school since
July
July 17th.
17th. Ooh,
Yeah, wow.
that's a short summer.
Yeah. Hands-on activities.
NASA science.
NASA, very cool.
That's cool. I don't even know what it is.
Route in the classroom. How cool. First time teaching ninth grade. You got this. Let us know if you
You
have any
got you covered.
questions.
Yeah, my physical science. Oh man, I used it so much. Doing so.
Man.
I love the beginning of the school year. There was so much energy,
Yep.
it was really busy as a teacher, but you had that honeymoon phase where everything seemed to be clicking and
I like that. The honeymoon
yeah,
phase.
that's real.
It's true, but it was great. I mean, the whole
That's
year was good,
awesome.
but it's just that first thing.
All right, it looks like we're about 2 minutes after the hour. Just to make the most time of our or the most of our time together today, I just wanted to hop into some quick housekeeping items before I pass the presentation over to our presenters. So we'll go to the next slide. And I think I accidentally oh, maybe I didn't add it back in. Well, I'll just say the housekeeping items out loud. Basically, there's two big things. First and foremost, you will get a recording of today's webinar that'll be sent straight to your inbox as soon as it's ready. We just take about 3 to 5 business days to edit, so keep an eye on your inbox. It's coming to you. We're also going to email you a link to the resources folder that I'm going to drop in the chat as soon as I'm done talking. That's just got some further reading for you all, so I'll go ahead and make sure that you have access to that. And then, of course, we want to answer your questions, so please feel free to leave all of your questions in the chat. Like I said, Nüs and Josh will keep an eye on that, and if we happen to not get to your question, please email us. You can reach us at support@vernier.com, and then we also have a phone number and a chat on our website where you can reach out to us as well. That being said, I will pass you off to our presenters, and thank you again for joining us today.
Hey guys, my name is Nüs Hisim. I'm a chemistry specialist here at Vernier. I taught in Maryland for 34 years, chemistry and physics. It's one of those, I love volunteering. I love sharing STEM. Here at Vernier, I write curriculum. I do presentations, even national ones. Hey, Christine in New York, we're going to be at Stanny's. In Syracuse in November. So if you happen to be there, I'd love to meet you in person. So Josh, who are you?
I'm Josh. I am a physics and engineering specialist here at Vernier. I also taught on the East Coast in Northern Virginia, Fairfax County. I taught all levels of physics there. I taught a couple of engineering courses and was a robotics mentor for our high school team. I've got 4 kids of my own. The oldest is in high school now, and the youngest is entering the 3rd grade. We really like to ride bikes together, play Lego together. It keeps me busy. We're really excited to have you here with us today. We're going to kind of talk about some real Vernier essentials. So we're going to kind of talk about The six are kind of like our six most popular probes, the ones you're most likely to have in your classroom, or if you're getting started, the ones you probably would want to get right from the get-go. And we'll talk about each of those probes, and as we do, we'll talk about things like the kinds of activities you would do with these probes. We'll talk a little bit about the software and the software features along the way as we do. We're gonna as Dylan said, we're gonna kind of monitor the chat as we go, and some questions we'll probably just answer out loud like this. Dylan will, if we miss one and if Dylan feels like it's important, she'll probably interrupt us and have us, and then we'll review questions also at the end. So we plan on spending a few minutes on each. We'll kind of demo some of these probes for you, and then at the end, we'll have some opportunity to answer questions.
Yep. So let's get started. So we'll start with probably the sensor that I think just about everybody can find a use for it. The temp probe, it's just got so many uses. Let me bring a camera up here and show you. I got one set up here, and I started the year with the temp probe back in probably back in the 2000s when I got challenged by one of the writers here at Vernier to do an experiment day one of school, and I used to use this temp probe, this style with my students. The Go Direct ones, they are fantastic. They didn't exist when I was in the classroom. There was a Go Wireless version, but this one's actually better. And when you plug this thing in, so all of these new ones come with a USB cable, and you don't need an interface. With these, you can connect them directly with the USB cable that comes with them, or you can connect them by Bluetooth wireless. But I would suggest to you, if you have any of these in your school, plug them in and fire up graphical analysis. Even the older style one, it'll take an interface, but just plug it in, fire up graphical analysis, and do an experiment like hot hand, where you just hold on to the end of the probe and challenge your students to get the highest temperature using only their body. Now, no internal body temperatures. Don't be sticking it in your mouth. But it's kind of fun to see, how you can get the highest temperature possible. So this is a great probe to start the school year with. I set up a pretty standard experiment with temperature probes. This is used in chemistry and biology to determine the heat of combustion of something. It could be a fuel like a paraffin. It could be sometimes we burn different kinds of food. This would be the experimental setup. A very common experiment I used to do, food and fuels, when I was teaching. So a couple of things to be aware of, though, with the probes. If you have this style, let me get this experimental setup out of the way. If you have this style with the cable, please don't wrap the cable around the probe. If you do that, you put a lot of strain right here. And if the wire breaks here, we can't fix it. So when you're storing the cable, wrap it around itself, use a rubber band, or I love using these Velcro strips. The other thing to be aware of is the probe is good to about 120, 130 degrees Celsius. Much beyond that, you're going to damage the probe. Don't put it in a flame. Don't put it on a hot plate. Okay, that will damage the probe, and unfortunately, that's not a warranty repair, or it's definitely something that can't be fixed. So you want to be aware of that when you're using the temp probes. Good for the most common things people do, maybe -10 to 130 Celsius. Anything beyond that, if you want temperatures beyond that, you need to be looking at our thermocouple, which is a whole different sensor. So just be aware of that. Josh, why don't you, do I get to do the next one too?
Yeah.
Oh, okay, cool. So go ahead and put me on here. The next most common chemistry biology probe is the pH sensor. We have a lot of flavors of these. The ones you're seeing on the screen are the most economical ones. And so what do you use them with? Well, in physical science and chemistry, not unusual to look at the pH of acids and bases and things that are, you might even find around the house. Titrations. I mean, boy, how many titrations have I done with a pH probe? Even things like beverages, biology, environmental science, earth science classes, the pH of water in the environment, soil pH. I have to make a slurry out of it, but you can measure the soil. A couple things to be aware of it. The pH probe, you have to store it in the storage solution that comes with it. Let me show you mine here. I want to show you a little power tip. Okay, so these pH probes, all of them come with this little bottle. And when your students are using it, my suggestion is to put a nickel under the cap, okay, of the storage bottle. So you want to loosen the bottle, pull the probe out after you've loosened the bottle because that grommet gets smaller when you tighten it. So you want to make sure it's loose. Remove the cap, stick a nickel under there, put the cap back on, and then when your students knock the bottle over, you don't lose the storage solution. I used to have a cup of nickels in my classroom, in my demo table just for that purpose. And of course, this is the probe that I was using most of the time. So a very easy probe to use, but you need to be careful. One is the whole idea of using the storage solution. The other thing to be aware of is that glass bulb on the end of the probe cannot be repaired. Okay, so if you break that bulb, you now have a Harry Potter wand. You can start casting spells. The nice thing about the newer variety of these is that you can replace the electrode without having to buy the whole sensor. So if you buy the newer ones to replace older pH probes, be aware that you don't, if and when the students break that, how do they break it? Most common thing is catching it on the edge of a beaker as they're lowering it in, or a flask. And so once again, if they break it, we can't repair it, but at least with the Go Direct version, you can buy just the electrode without having to buy the amplifier. The amplifier is kind of universal and it works with numerous electrodes, including this one. And we have a flat one that some people think is a little more durable. We have a glass one. And so there's some options there when you're when you buy the Go Direct version of the pH probe. So great tool. And you can see household acids and bases, acid-base titration. Those are the most common uses of that sensor.
So Nüs, there's a question in the chat about that storage solution. Should you like replace it frequently? Does it need to be replaced frequently, like every year or like every month?
So what happened, I taught in Maryland, very humid state. Josh taught in Northern Virginia, and we never did a workshop together, and we were like an hour
like neighbors. Yeah.
Anyway, Maryland, very humid, and what would happen is the storage solution would turn black in a year. Now that's because it was growing a mold, and it just so annoying. So what I had my more advanced students do is replace the storage solution. What is it? It's a pH 4 buffer. And every 100 milliliters of buffer has 10 grams of potassium chloride, KCl. And that's it. Now, if you buy it from Vernier, it also has a mold inhibitor, but I'm telling you right now, in Maryland, it didn't work very well. So we had to brush out the bottles, and that you have to take the end of the probe. The mold doesn't hurt it, but you have to take the end of the probe and put it in under running water. And so that's every year. We did that every year before we started using them, because I would say 80% of the bottles were black. Okay, Vernier does sell the storage solution, not crazy expensive. I think it's $20 for 500 milliliters, but you can make it yourself. We have buffer capsules if you want to get them from us to help you make the storage solution. That's a great question. 10 grams per liter of potassium chloride, KCl. Okay. Pardon me, 10 gram, no, not 10 grams per liter, 10 grams per zero point 0.1 liters, 100 milliliters. So 100 milliliters of pH 4 buffer, add 10 grams of KCl, potassium chloride. Can you add some sodium benzoate as a mold inhibitor? I'm not sure. I don't know the answer to that one. I'd have to look at the SDS of our storage solution to see if that's what they use for the mold inhibitor. I'm telling you, it didn't work. So I wouldn't worry about it. If you're going to replace the solution every year, I don't think it's worth the extra expense. Can you add some? Yeah, okay. So any other questions about this? All right,
Okay.
physics time.
Let's talk about something that doesn't mold.
Ah,
So we've made a variety of motion detectors over the years. If you've seen our LabQuest sensors, you're probably familiar with this kind of green one. So it came in like a teal blue for many years. Had this kind of pivoting head to it. The newest and latest version is part of our Go Direct line, and it's just like a little cube, but the same idea. It has that special transducer here, microphone element that picks up the sound waves. The way that the motion detector works is it produces an ultrasonic, click. We do hear a click, but what it's actually measuring is an ultrasonic 40 kilohertz, and it listens for the echo of that sound wave back to it. So what you see here, it looks kind of like an eye, but it's really more like an ear. It's a very sensitive microphone. It's tuned to that 40 kilohertz signal. And it just uses the round trip time of that sound wave to figure out how far away an object is. Now, when you think about that, this eye, this ear here, it's really one dimensional. It's kind of like only things directly in, it can only measure things directly in front of it. So you could use this, for instance, to measure the motion of a student back and forth in front of it. They're moving back and forth in front of this thing. You can measure their distance to the motion detector. You could put it on the tabletop and toss a ball above it to measure, the height of the ball versus time. We have a popular lab where you point it towards the ground and you drop coffee filters beneath it. And then it's very easy to measure the terminal velocity of those coffee filters. For the most part, it works well with big things, people and balls and that sort of thing. You can also put it on the end of a dynamics track and measure like a cart moving back and forth in front of it. It really is a great tool. When you look at the other ways of measuring motion, things like photo gates or the sensor carts, they work well in their particular niche, but the motion detector really is great for all sorts of investigations. I used to use the motion detector on the first day of school. We talk about first day of school activities. And I would have my students do graph matching. This is where graphical analysis generates a position graph, and then students have to move to try to reinterpret that graph and move in such a way that they match the graph that graphical has generated. I'm going to do a real quick ball toss with here, just so you can kind of see the sensor, how it works a little bit, and then also our graphical analysis app. So I'm going to pull up graphical here. I'm going to do this over here, and I'm going to find my motion detector. I'm just connecting via Bluetooth, and once I've connected, it'll start clicking. It's just kind of sending out little blips. It lets you know that it's on and it's running. And you can see right now I've got it pointed towards the ceiling, which is just looks like it's just about 2 meters away. I'm going to pull up my camera here, and I'm going to put my motion detector here on the corner. And what I've got is this is just a little Nerf ball, and I'm going to take it and I'm going to throw this above the motion detector so that I can see the motion of the ball while it's in free fall. Nüs, would you help me out here? I'm going to stand here. If you'll just hit collect. Yeah.
Okay, you ready?
Yep.
Go.
All right. Look, we got some noise there, but I got a pretty good toss in there. Our graphical analysis app, you can see just by default, it gives me position versus time. I'm going to zoom in on the toss itself and just zoom in here. You can see I get this nice parabola. If I was teaching a physics class, I might ask students to do a curve fit here and tell me a little bit about, interpret the fitting parameters. I can click and drag the region that I want to apply a curve fit to. And then from my menu, I can choose a quadratic fit. It looks like a nice downward facing parabola there. And graphical analysis gives me a nice, it gives me some nice values here. So as a physics teacher, it's hard for me to resist this first value, right? Tells me in terms of my fit here, it's not very useful in terms of real life because my fit goes way down here. But the first value, this B value, is the speed or initial speed of the ball in meters per second. And then the second parameter, it shows up as A, but that's like the mathematical A. That's not A acceleration. In fact, A acceleration is twice this A mathematical A. So if I double that, I'm going to get something close to 9.4-ish, which is pretty close to the acceleration due to gravity. So that's pretty good. You might use a motion detector to talk about the motion of the ball. You're talking about motion and one-dimensional motion, that sort of thing. And then later in the year, when you're talking about conservation of energy, you might do a similar sort of activity and take this position data and transform it into gravitational potential energy. The motion detector, graphical analysis also calculates velocity and acceleration as well, based on your position data. So you could take that velocity data and transform it into kinetic energy and talk about the whole conservation of mechanical energy. It's great. All right, I'm going to switch gears here a little bit, and I'm going to disconnect from my motion detector. All right, the next sensor that I want to share is the force and acceleration sensor. This is another one of those ones that has just lots and lots of uses. Our older LabQuest force sensor just measured force. It was called our dual range force sensor, and it has two settings. That's what the dual range is, a smaller setting and then a larger setting. The Go Direct force and acceleration sensor has that same range. It just automatically scales between the 10 Newton range and the 50 Newton range. It also has an accelerometer built into it, a 3-axis accelerometer and a 3-axis gyro. So the accelerometer measures changes in motion along each of the 3 axes. And then the gyro measures angular velocity about each of the 3 axes. And because it can measure so much, there's lots that you can do with this. You can the most common thing is you're going to take it and you're going to drag something across the tabletop to measure the friction, maybe a shoe or something like that. You might hang it off of a string and swing it around your head to measure centripetal force and accelerate. You can use the z-axis of the gyro to measure your angular velocity there. You might swap out the hook for a bumper and push on things. I used to have students roll bowling balls, and we would take a mallet and kind of push on the bowling ball with our mallet, tap on it to simulate that idea. And then with something like this, you could actually measure how much force with the impulse you're applying to the ball. I'm going to switch through my camera view here so that I can show one of the fun things that you can do is it takes advantage of all that the sensor can do is you can hang it from a spring, and you can measure both force and acceleration at the same time. So I'm going to turn on my force and acceleration sensor there. I'm going to connect it to graphical analysis here. And by default, it's looking for force, but I'm going to open my sensor channels here, and I'm going to add x-axis acceleration. So now I have both force and acceleration, and I'll zero those. I'm going to get this guy as close to rest as I can. I'm going to zero those two quantities. First, I'm going to make this a little bit bigger, just so it's a little easier to see. And okay. And I'll zero these. And then I'm going to get my force and acceleration sensor bobbing, and I'll collect some data here. And it's really, you can see that these two curves are in sync with each other. When one is big, the other one is big. When one is zero, the other one is nearly zero, and so on. And one of the great things about this is we know that force and acceleration are related. That's Newton's second law. It's like the thing. And we could go in here, we could plot one versus the other if we wanted to. I'm just going to have one graph, and rather than plot force versus time, I'm going to plot it versus acceleration. And I end up with this nice graph here. I'm going to take, because I'm like that, I'm going to change. And so I can see the actual data points here. And you can see they follow a very distinct pattern. And if I do a curve fit on those, which is a linear curve fit, I get force versus acceleration. And I know that the slope of that curve there is the mass of the, which is about 80 grams. Works out real well.
Really?
Yeah.
Whoa, I
Yeah.
love that.
It
Just
works.
a little spring.
Yeah, just a spring. Yeah, and you get Newton's second law. I actually, I don't know if you read that, The Martian,
Yeah.
his follow-up book, and it features a physics teacher that does this on a to figure out whether the acceleration due to
Now I'm
gravity.
gonna go back and
It's pretty good.
That was a
Anyway,
good book.
yeah. It was,
Yeah.
so the force and acceleration sensor, it's another one of these tools. It's so versatile. You'll use it all year long. It really is a wonderful thing to have, wonderful tool to have in your lab. All right, I'm going to close out of this, and I think up next is
Biology.
O2, yeah.
All right. Okay. Yeah. We have a couple of biosensors that we're gonna show here. And so one is the oxygen sensor, and the other one is the carbon dioxide sensor. And we'll take a look at uh, um, both of them and kind of get a little thought about them. One couple things to be aware of that we have had this question come up. As you can see, no, not for water. So these are gas sensors that we're going to be looking at. We do sell a dissolved oxygen sensor. That is popular in biology and environmental science classes. Maybe not the top sensor. We were trying to hit the top ones of this presentation today. So, if you want to measure the dissolved oxygen level, we do sell a sensor for that. We do not sell a sensor for dissolved carbon dioxide. So you would have to think about that as in relation to pH if you were trying to do something with carbon dioxide dissolving in water. The other thing to be aware of, the oxygen sensor needs to be stored vertically. It doesn't hurt it to lay it on its side, but you'll get bad data for a while. There's a gel in the sensing element, and that gel needs to be lined up vertically. So if that sensor is laying on its side over the summer, or even when you get them shipped from us, make sure that you keep them in a vertical axis, at least for an hour or two before class, so that it gives that thing a chance to level out. The other thing to be aware of is that gel does degrade over time. And so after 3 to 5 years, you may find that you just can't get good oxygen data from your sensor. And that's because the gel in the actual sensing element needs to be replaced. And we're happy to do that for you. There's a bit of a charge because we have to replace that sensing element, and there's a cost that's associated with that. But it's much cheaper than buying a whole new sensor. And we have them in both the old style, the LabQuest style, with that many people are familiar with. Those still work with graphical analysis. If you have a oxygen gas sensor that's this form factor, this cylindrical form factor with a white plug, you can plug that in. We can still repair it for you if it needs repair, and you can collect data with graphical analysis. The sister sensor is the, oops, what's going on, Josh? I'll leave it to you. There we go. The carbon dioxide sensor, you can see, follows the same form factor. This one doesn't have the orientation issue. It can lay on its side. It once again, not for water. Don't. You'll only only put it in water once, and then you'll find out. Humidity is a factor. The sensor uses infrared light to sense the CO2. If there's water in there, that will interfere with the reading. So you don't want an atmosphere that's too humid. Similar to the oxygen sensor, common experiments are going to be cell respiration, photosynthesis. Those are very, very common. You could put critters in the bottle and you can measure the production of CO2 and the consumption of oxygen gas simultaneously if you want. In fact, just for you, I did some fresh data this morning. Let me bring it up and I'll show you what it looks like. Here, I've got the sensor sitting here. There's the two sensors connected to one bottle. When you buy these sensors, they come with a 250 milliliter Nalgene bottle. Every one of them comes that way, but they all come individually. You can buy from us a bottle that has an extra hole in it. We do sell the grommets, so if you want to make your own bottles, you can also do that, and so you can connect two at once. And so some of you bio folks might recognize I've got some spinach in there. So this is the setup that I used this morning to get some data to share with you. It takes a little while, and I just didn't see the point in just us sitting here twiddling our thumbs while we were waiting for the data. So I wanted to show you a couple things while I do this. Let me grab that data file. Oh, let me turn these on too, just so that we can connect to them. It'll make it look a little bit nicer. And so here's the file I collected this morning. And let me add some sensors to this. And so I'll add the CO2 and O2 sensor. There's the CO2 sensor. A lot of these sensors, like Josh mentioned with the force and acceleration, they actually have some other things built in. For example, the CO2 sensor has a temperature probe built in, and it measures relative humidity. Let me bring up the oxygen gas sensor. That one also has multiple channels of temperature being most important. RTC means remove the temperature compensation. But I'm going to leave it like this because that's how I collected the data this morning. And I used to generate this file, I used our Graphical Analysis Pro app. And so I took a little short video. This is like a 3-second video just of the setup in front of my laptop that I used to collect the data. And you can see this was super simple. And remember now, this is a chemistry teacher doing this. So, but super simple. I did this. I wrapped the bottle in aluminum foil in order to block as much light. So to simulate the dark cycle, so you can see that carbon dioxide was being produced and oxygen was being consumed. And, just like Josh was showing earlier, we can figure out the rate at which the carbon dioxide was being produced. And so I can do a curve fit on that graph. Linear seems the most appropriate. And so there I was making carbon dioxide at a certain rate. Same with oxygen gas. If I wanted to know the average over the whole 5-minute run, I could do the same sort of thing and do a curve fit to do that. This software is amazing. And folks, if I was in the classroom, I mean, Josh and I are Logger Pro fans from way back when, and we feel your pain. But that software, unfortunately, is starting to get to the point where it's a challenge. If I was in the classroom today, I would switch to graphical analysis in a heartbeat because there's just so much good stuff. Did you want to add to that, Josh?
Oh, I'll talk about graphical here in a minute.
Yeah, it's just one great piece of software. And if you pro it up, then you have this option of adding videos and all kinds of other things. But you can collect all this data with the free version of graphical analysis. You don't need the pro version. It runs. I'll leave it to Josh to talk about it. But the point being is that it's a wonderful piece of software and it works with your old sensors. So this whole experiment that I did this morning, if I wanted to do it with the wired sensors, I could have. I could have done the exact same thing with no loss or anything like that. Did I see something pop up there?
There was one question in chat. You mentioned that the gel and the O2 gas sensor, it ages and over several years, they'll need to have it replaced. The CO2 sensor doesn't have a similar sort of
No,
You know,
CO2 sensor, they last a really long time. It does not have the gel. You should get at least 5 years out of that sensor. We warranty our sensors for 5 years, but honestly, folks, we try to repair them for you for a long time past then. And so, no, there is no time when the CO2 sensor is going to die. That one's going to last for a long time. But unfortunately, O2, by the nature of its form factor, whether it's old or new, you'll need to replace the gel, but not the CO2. Any other thoughts?
I'd say I'd just add to that the vast majority of our probes, it's not like they age out. They're sitting on the shelf. You pick it up, it'll work just as well for you in September as it does in June. The O2 sensor is one that needs some care, and there are a few other little ones like that for the most part. But when I was in the classroom, I was using motion detectors that were 10 years old, and they're still kicking.
Same here.
Yeah,
Temperature probes from the 90s were
yeah,
working. Colorimeters from the
yeah.
90s that were working. Yeah, the Vernier stuff, generally speaking, I mean, I know we work for the company and we're biased, but when we were in the classroom, why did we use Vernier equipment? Part of the reason was it was a great investment. We could
Yeah.
use it for years and years and years. And are you going to talk about the next webinar?
Yeah.
Or are you okay?
Oh,
So
yeah,
okay,
we'll
okay,
get
we
to.
should talk about that because a lot of schools are finding Vernier equipment when Mr. Smith retires, and folks, some of that stuff is still good, and we'll
Yeah,
talk more about that in a bit.
most of it is.
I'll tag you back
Yeah,
to talk
so
about graphical analysis.
let's talk a little bit about graphical analysis. So the software that we've been using here is graphical analysis, Vernier graphical analysis. It is relatively new. We started developing it about 7 or 8 years ago. Well, we've had a graphical analysis software app for a long, long time, but we kind of really started revamping it about 7 or 8 years ago. And it's designed for modern devices. Logger Pro was designed in a different era of computing, but graphical analysis, it's friendly to touch screens. It has a modern look and feel. It's compatible with all of our sensors. So the newer GoDirect sensors that will just connect via Bluetooth or USB to your device, or your older LabQuest interfaces and sensors, it'll work with them as well. It's available on Windows, Mac, iOS, Android, Chrome. It all looks and feels the same on all those platforms. So if your students have Chromebooks and you have a PC a laptop, it'll work just the same for you as it does for them. Most recently, there's a version that just runs within the browser. So if you have a Chrome browser and you go to the address bar and you type in graphicalanalysis.app, and hit go, it'll load the app just within the browser itself. Just uses the infrastructure of the browser to tell you to bring you that app. That's very convenient. That means you don't have to install anything. It just works. There are two versions of graphical analysis. There's a free, like a basic version that's free. And that, I don't think, was there anything we've done here today? Oh, the video. For the most part, you'll find that it covers all your core data collection and analysis. The Pro version, which requires a license, you pay for a license, that adds some things like the video embedding and syncing that Nüs showed a little bit earlier. It includes some advanced analysis techniques, so things like FFTs and fancy calculated columns and that sort of thing. It also has some remote learning tools that are really handy. So you could collect data in your classroom and stream it to students at home. They would just get the data in graphical analysis on their own device at home. It really is a great tool, easy to use. Like I said, because that basic version is free, if you want to try it out right now, just open up Chrome, type in graphicalanalysis.app, and you can play around with it. This is kind of like the splash screen you see here. And then obviously sensor data collection is what we do. That's kind of our thing. And so that's the first option there. But a lot of people will just use it for manual entry. They'll just plug in, they'll enter their data in the data table and be able to use the analysis tools that are built into graphical analysis that way. this data sharing option is a way to get data from your device or from your LabQuest to somebody else's. So you can kind of stream that data over Wi-Fi or the internet. All right.
We're talking about getting back to school, and we just want to make some suggestions about what you might do if you're using our stuff. First thing to do, we did this once a year at my school, unless there was an emergency. We did it once a year, and that is we updated stuff. Software, the updates are free. If you have Logger Pro installed and you need to update it, it doesn't cost anything to do that. All of our LabQuests have software that runs their little computers. They have little softwares on them that run. Those updates are free. The nice thing about the LabQuest 3 is that one can be updated over the air. So if you can put it on your Wi-Fi network, you don't even need a flash drive. You can just go to the update app that's on the LabQuest 3, and it will look for the update and install it automatically. The 2 and the original LabQuest, you do have to use a flash drive, but it's still not a very difficult process. I would set up flash drives, give them to my students. They thought they were really hot stuff if they were helping me to update the LabQuest. So be aware of that. For those of you that have LabQuests in your school, it may surprise you to find out, if you don't know already, that you may also own this piece of software called LabQuest Viewer. LabQuest Viewer works with LabQuest 2s and LabQuest 3s. It allows you to see what's going on a LabQuest, control a LabQuest. I used it when I taught AP chemistry with spectrophotometers, where we would compare spectra of food dyes to talk about absorbance and transmittance. And I would put all the devices up on the screen, and then we would say group 2 and group 3, and we would compare them. And it's a wonderful piece of software. So if you own LabQuests, you're not sure, send us an email, support@vernier.com. We can look it up and see if your school already owns it. Like all our software, it's a one-time fee that's for your whole school. So you don't buy it for every teacher, or you just buy one copy. But you may already own it and may not realize that you do. So please let us look that up for you and save you the trouble. And if you need help with figuring out how to work it, we are welcome to do that. I don't know. Are we talking about webinars?
Yeah, so we should talk about some webinars. So later this week, we have a webinar all about what happens if you've got a cabinet full of Vernier stuff, you haven't used it before. How am I going to connect this? How am I going to use this? Or you've got some older Vernier stuff, but your students are using Chromebooks. How do I get those to get those things together? That's, I think, on Thursday. I think Dylan mentioned in the chat. Later, I think next month, we have a webinar all about graphical analysis. So if you're new to graphical analysis, or you kind of want to get the inside track there, there's that webinar for graphical analysis. So if you ever send us an email, or you call, or you come to chat, it's likely you end up talking to Nüs or me. There are about a dozen of us that answer those kinds of questions. We're all former teachers ourselves. We kind of know where you're coming from. We're happy to talk to you, help you figure out what you need, or fix things that you need to. We also do trainings, like one-on-one or one with a department sort of trainings over Zoom. We do those pretty frequently. And we can do a lot in an hour, and just the easy 1 hour trainings are free. So we're happy to do those as well. Sometimes it's nice to have a little bit easier back and forth. You say, take a picture and say, I got this stuff, I'm not sure how to use it. We can gather the same things on our side and can meet over Zoom and talk through how you could best make use of that equipment.
Very popular. I do many of those. So do you, where it's like Mr. Smith retired and we opened a cabinet and some of these things have never been opened before. How do you use these? That's what the webinar on Thursday is all about. But we also love to meet with you with your equipment and walk you through how to connect it and collect data and analyze. So please let us help you. Is there anything else that we missed?
I'm scrolling through these. Dylan did a wonderful job here answering questions in the chat, Rockstar. I'm not sure. I don't know if we have any
So
outstanding questions.
there was one question about sensors and TI-84 calculators, and it's a bit of a lengthy description. Yes, we have sensors that will work with TI-84 calculators. They don't plug directly in. They require an interface. It's called an Easy Link. And so if you need to talk to us about that, please send us an email, give us a call, go into chat. I started out on Apple II computers, and guess what? My first piece of software was graphical analysis. It's that name has been reused over and over again. But in the 90s, it was all about calculators. It was just couldn't afford computers. And so I'm a specialist with the calculators. We have a couple other people. Please let us help you. Yes, if you have a white plug sensor that is simple, temperature, pressure, pH, force, you can use that with a TI-84 calculator. So please let us help you. Just contact us. I think that's the last slide, right? Is the contact slide?
Yeah.
Yep. So
It's like there's one last question here. Someone wants to make the buffer solution themselves.
So what I need you to do, Shannon, is send me an email or just support at Vernier or chemistry@vernier.com. And if you want to make the buffer yourself, I need to send you some instructions. Basically, it's built around a chemical called potassium hydrogen phthalate. I can walk you through that. We do sell buffer capsules that makes it a lot easier than you having to scrape up the chemicals. But like I said, there's different recipes for making buffers, and you and I need to talk. So chemistry@vernier.com, and I can give you the recipe for how to make a pH 4 buffer.
We have email addresses. So if you got a physics specific question, you can email physics@vernier.com or biology@vernier.com. It helps. Just one less step routing it to the right person here.
Yep. So Dylan, what else did we miss?
I just wanted to ask everyone to give us some feedback in the survey there. Go ahead and click the link that I just dropped into the chat and let us know how we did. If I would recommend that you send any questions on over to the team as they recommended. So yes, that's good.
Okay.
All right.
Happy school year. Have a lot of fun, folks. I did it for a long time and I love it. I still volunteer in schools. I think didn't I volunteer in your daughter's
Yeah,
school?
be brave. Yeah.
Because we love to interact with students. And so we're looking forward to hearing great things. Let us know what we can do to help.
Bye, all.